Science 4. Properties of matter. Objectives. At the end of the lesson, you should be able to describe matter. Name the 3 states of matter. Identify the properties of matter. Differentiate physical properties from chemical properties. Classify the materials according to whether they are biodegradable or non-biodegradable. Identify the effects of decaying materials to one's health and safety. Look at the picture of a kitchen. Can you name some materials found in the kitchen? The kitchen contains materials of various kinds and uses. These materials have properties that are suited for their purposes. Food products, utensils, and other materials should be used and stored properly according to their properties. Improper use and storage of these products may be harmful to one's health. All the materials found in the kitchen are examples of matter. Matter is anything that occupies space and has mass and volume. Everything around us is made up of matter, from the air we breathe, to the water we drink, and even our own bodies, planet Earth, and all the stars, planets, and moons in the universe. Matter has properties, has physical and chemical properties. Physical properties can be observed or measured without changing the composition of the matter. They include the object state such as solid, liquid, and gas. The physical properties of matter can be extensive or intensive. Examples of these properties are mass, weight, volume, width, and height. Mass and weight are often confused. Mass is the amount of matter in an object. It is expressed in grams and kilogram. Weight is the amount of force acting on the object because of gravity. The mass of an object remains the same regardless of where the object is, while the weight of an object changes depending on the strength of the pull of gravity on the object. Earth has greater gravity than the moon. This is the reason why your weight on the moon is only 1/6 of your weight on Earth. Let's say that you weigh 50 kilograms on Earth. Divide this figure by 6 and you get 9 kilograms, which will be your weight on the moon. Which has a greater mass, the chair or the table? When objects are made of the same material, the bigger object has the greater mass. Since the table is bigger than the chair, its mass is greater. Volume is the amount of space that matter occupies. It is expressed in cubic centimeters for solids and milliliters for liquids. To determine the volume of a regularly shaped solid, you have to measure its length, width, and height with a ruler. Then, compute for the volume using the following formula. Volume is equal to length times width times height. If an object's length is 10 centimeters, the width is 5 centimeters, and the height is 2 centimeters, we will multiply the numbers as follows. 10 centimeters times 5 centimeters, times height is 2 centimeters, is equal to 100 cubic centimeters. To get the volume of an irregular solid such as marble or a piece of rock, you may use the displacement method. In this method, you will need a graduated cylinder and some water. The graduated cylinder is an instrument for measuring the volume of liquids. Let's say that we have 200 milliliters of water in a cylinder. If you drop a rock into the water, the level of the water rises to 240 milliliters. Get the volume of the rock by subtracting the amount of water without the rock from the one with it. 240 milliliters minus 200 milliliters is equal to 40 milliliters. Thus, the volume of the rock is 40 milliliters. Intensive properties do not depend on the amount or size of matter. color, hardness, brittleness, elasticity, malleability, ductility, porosity, solubility, and density are all intensive properties of matter. Have you ever wondered why a small piece of rock sinks in the water while a big metal ship floats? The phenomenon can be explained by the density of matter. Density is the quantity of matter per unit volume. For example, a cork has a mass of 10 grams and a volume of 15 milliliters. What is its density? Density is mass divided by volume. The density of a cork is 0.67 grams per milliliter. Density tells whether an object will sink or float in a certain substance. The density of water is 1 gram per cubic centimeter. If the density of the object is greater than 1 gram per cubic centimeter, it will sink in water. If the density is less than 1 gram per cubic centimeter, it will float on water. Going back to our cork example, the cork will float on water because the density is less than 1 gram per cubic centimeter. What happens when you pour liquid on a sponge? Does the same thing happen when you pour the same amount of liquid on a plastic sheet? The liquid is absorbed by the sponge but not by the plastic. This is because a sponge is porous while plastic is not. Porous materials allow liquids or gases to pass through them. Porosity is the ability of a material to absorb liquid. It also refers to the presence of pores or the holes, or spaces that allow liquid to pass through. The sponge, cotton ball, tissue paper, and face towel are porous materials since they can absorb or suck up liquid. On the other hand, plastics, metals, and ceramics are non-porous since they cannot absorb or suck up liquid. If you have seen pictures of a car that had rammed a concrete wall, you must have noticed how the car ended up squashed. This is because the wall was too hard for the car's impact. Hardness is the special property of matter that allows it to resist being scratched and dented. In the case of the wall, it may have been scratched or smashed in some parts, but because of the hardness of the concrete, it was able to resist the impact of the car's crash. The wall may have sustained damage but only less than the damage on the car. What could happen when you drop a glass bottle onto the floor? What is it about that could cause this outcome? Glass is among the materials with the special property of brittleness or the ability to break easily. Materials that break easily are called brittle. Chalk and ceramics are two other materials that exhibit brittleness. If you were to remove the rubber or plastic from around a piece of electric wire, you will find a very thin piece of wire made of copper. The piece of copper wire had been stretched thinly because copper is a ductile material. Ductility is the ability of a material to be drawn into fine or thin wires. Tungsten is another example of ductile material. Have you experienced stretching a rubber band, then loosening your hold on it? What did you observe? A rubber band is a material that exhibits elasticity or the ability of material to be stretched and to return to its original shape and size after being stretched. Rubber bands and garters are examples of elastic materials. Unlike rubber bands, paper clips and plastic straws cannot be stretched. However, they can be bent, turned, or twisted because they have the special property called flexibility, or the ability of a material to bend without breaking. If ductile materials can be stretched into thin wires, some materials can be forged, pressed, beaten, or rolled into thin sheets. The materials exhibit the special property called malleability. They include various metals such as copper, silver, aluminum, and lead, with pure gold as the most malleable. Tenacity is the special property of matter that can resist being pulled apart. For example, metals have greater tenacity than wood. It is harder to pull the components of a metal apart than it would be to pull the components of a piece of wood apart. What happens when you add sugar to a glass of water and stir the water? Can you still see the granules of sugar after stirring? Sugar is a material that exhibits solubility, or the ability of a material to be dissolved in a liquid. Other than their physical properties, some objects also have chemical properties. The chemical properties of matter are characteristics that can only be observed after the material undergoes a change in composition. Suppose you have a piece of paper. If you throw it into a fire, what do you think will happen to it? Will it stay the same? No, because from being a piece of paper, it will turn into ashes. This property is known as flammability. Flammability is the ability of a material to catch fire. This is a chemical property because combustion is a chemical change. Gasoline, for instance, is highly flammable. When it burns, it changes to carbon dioxide and water, which have different properties from gasoline. Other flammable materials include paper, wood, paint, alcohol, and kerosene. Another chemical property of some matter is being prone to corrosion or damage on material when exposed to different substances like water, air, and acids. An example of corrosion that may be familiar to you is rusting or the reaction of iron with water and oxygen. When iron is exposed to air, it reacts with oxygen in the presence of moisture. The reaction produces iron oxide or rust. Rust makes iron weak. Iron grills at home are painted to prevent corrosion. Coating this material with paint prevents this material from reacting with oxygen in the air. What happens when waste like banana peeling, leftover food, and dried leaves are left buried in the soil? Days after these wastes are buried, they break down and become part of the soil. The breaking down of organic matter into simpler forms is called decomposition. This process involves chemical change. Microorganisms like bacteria and fungi break down organic matter, turning it into different substances. The substance becomes part of the soil as minerals that are vital for the growth of plants. Wastes that decay are called biodegradable materials. Not all waste, however, can be broken down by decomposers. Some wastes, such as plastics, metals, and glasses, do not decay. These materials are called nonbiodegradable materials. When they are not properly disposed of, they can pollute the environment and harm living things. Look around you. Can you identify biodegradable and non-biodegradable materials? Plants, humans, and animal wastes and paper are examples of biodegradable materials. Rubber, glass, metals, plastics, electronic parts, and medical wastes are examples of non-biodegradable materials. Materials decay at different rates. Biodegradable materials like paper may decay in 3 months. Non-biodegradable materials, such as plastic bags, may take 450 years to decay. What are the effects of decomposition? Decomposition is an important chemical process. When plants and animals die, the nutrients trapped in their bodies are released as they decompose. Decomposition makes sure that the ecosystem will never run out of nutrients. However, it has negative impacts on human health and the environment. It causes food spoilage and health problems. Food spoilage can be prevented by storing food properly. Leftover food must be placed in sealed containers and kept refrigerated. This food must be consumed within 3 to 4 days. Consuming spoiled food can cause food poisoning, a condition characterized by stomachache, vomiting, and diarrhea. When decaying wastes are not properly disposed of, they attract animals such as cockroaches, mosquitoes, mice, and flies. Mosquitoes can spread diseases such as dengue and malaria. The wastes of mice cause leptospirosis. Cockroaches and flies carry microorganisms that cause gastroenteritis and diarrhea. To prevent the spread of diseases, decaying wastes must be properly disposed of through composting. Composting is the process of burying biodegradable wastes in the soil. As the wastes break down, they become part of the soil, making it more fertile. To check how well you understood the lesson, let us have a short exercise. Identify what is being asked. 1. It is the property of matter which is responsible for the floating or sinking of objects in water. Answer. Density. 2. It is the ability of a material to absorb or suck up liquid. Answer. Porosity. 3. It is the ability of a material to decay easily or quickly. Answer. Biodegradability. 4. These are the properties of matter that can be observed or measured without changing the composition of matter. Answer. Physical properties. 5. These are the properties of matter that can only be observed after the material undergoes a change in composition. Answer. Chemical properties. You are awesome. You've got them right.